Okay, so I know that we are skipping around a little bit for this unit, but that's okay. So we're learning a new type of factoring method. You have never seen this one before. It's called factoring by grouping. When do you use this? You always use factoring by grouping when there are 4 terms in the polynomial. Okay, so anytime there are 4 terms in the polynomial, you are going to use factoring by grouping. So what would the steps be? First thing you are going to do is you are going to group the first 2 terms together and then factor out the GCF between those 2 terms. Step 3, you are going to group the last 2 terms, and then same thing, you are going to factor out the GCF between those 2. Here's the important part. You need to make sure that both parentheses are the same. So, and you'll see what I mean in just a second. So you're going to end up with 2 sets of parentheses in your groupings. Both need to be the same. And then you are going to factor those out. And then you'll be factored all of the way. So first example, the first example actually starts at step 5. So for our first example, we have already grouped the first and last 2 terms and pulled out a GCF. So this is what you will see. Let me do a better arrow. This is what you will see when you get to step 5, is what is shown in example 1. So we have x times y plus 2 plus 3 times y plus 2. What do you guys notice right off of the bat here? Both of them are being multiplied by y plus 2. Y plus 2 is your GCF here. So I'm going to write something off to the side. Just pay attention for right now. If I had x times a plus 3 times a, what would you do in this problem? Take out the a, right? So that would give me a times x plus 3. Same idea in example 1, except this time the GCF is y plus 2. So factor out the y plus 2, just like you factored out the a, and then what would be left on the inside? X plus 3. And that's your factoring. So this time, instead of factoring out a single term like a over here, you're factoring out a binomial. But it's the same term being multiplied by everything, so it's still a GCF. Okay, so example 2 is also just getting you used to factoring out a binomial instead of a single term. So we're going to be factoring it out, the binomial that's in common here. We have in example 2, 2s times u plus y minus y times u plus y minus y plus u. First of all 3 of my binomials are the same except for this one, which is y plus u. Technically, is y plus u the same as u plus y? So I'm going to rewrite it so that they all look the same. So that's 2s times u plus y minus y times u plus y minus, now what would the coefficient there be? A -1. So I'm going to write it just so that we don't lose it. So does everybody agree that what I just wrote is exactly the same as the original problem? Okay, good. What is the GCF here? Good, u plus y. So factor it out. U plus y times everything that's left over. What is left over? 2s minus y minus 1. All right, example 3. We have 2x to the third plus 6x squared plus x plus 3. This is what a problem will actually look like starting from the very beginning. Okay, so we are going to be starting from the very beginning on this problem. So first step is to group the first and the first 2 terms. So you're going to group 2x to the third and 6x squared. Second step was to factor out a GCF. Between those 2 terms, what is the GCF? 2x to the second. So factor that out. And that would leave me with x plus 3. Third step, was to group these last two terms, x plus 3. Is there a GCF in there? No, so I'm going to just write the 1 just so that we don't forget about it, and then in parentheses write the x plus 3. Are you guys okay with that? Okay. Now this is step 5. This is where we started in example 1. What do you guys notice about this particular step? Yeah, they both are being multiplied by x plus 3. So what are you going to do with it? Take it out. So you're going to factor out x plus 3. And you're going to be left with 2x squared plus 1. 2x squared plus 1 can't be factored anymore, so you are done. Sometimes it might end up as a difference of 2 squares, and then you'd have to factor again. But in this case, no. Not too bad? So let's look at example 4. So we have 4d to the 5th plus d to the 3rd plus 8d squared plus 2. Which 2 would I group first, guys? The first 2. And then I'm also going to later group the last 2. So what I want you all to do right now is factor out the GCF from each grouping. All right, ladies and gentlemen, from the green grouping, 4d to the 5th plus d to the 3rd, what's the GCF? D to the 3rd. Oops, that's not green. D to the 3rd. So then we would have 4d squared plus 1. And then what about the blue grouping? So plus 2 times 4d squared plus 1. Now, we always want our two parentheses to be exactly the same because that means we can factor them out. So factor out the 4d squared plus 1. What would I be left with? D to the 3rd plus 2. Neither one of them can be factored anymore. 4d squared plus 1, both of those are perfect squares, but are they a difference? No, because they're being added, so you just leave it the way that it is. Andrea?
If on the part where you divide before you factor out 4d squared plus 1, if they weren't the same, would you just leave them?
Good question. So if she asked if the first 2 steps where we're factoring out the GCFs, if our 2 parentheses did not come out the same, so if these did not look the same, then my initial thought would be that you did something incorrectly and that you want to double check and make sure you actually did factor out an entire GCF or that you divided correctly. Because I'll never give you a problem where they don't work. Okay, so example 5, I have 5x to the 4th minus 5x to the 3rd minus x plus 1. Now, when your second grouping is being subtracted, there is something different that you have to do. But let's take a look at the first one. So we have 5x to the 4th minus 5x to the 3rd. What's the GCF there? Good, 5x to the 3rd. So this is going to be x minus 1. Now, the one thing I want you guys to remember, anytime there is a negative attached to that second grouping, include it in your group. Why? Because that x is a negative, but we want our second parentheses to come out to x minus 1, right? We want them to be the same. So if this grouping is negative x plus 1, what should I factor out? A negative 1. So factor out a negative 1, and that makes negative x, positive x, minus 1. Okay, so it's the same as putting an addition in between the 2 groupings, but the negative has to stay attached to the term that comes right after it. So in order to get my 2 parentheses then to look the same, we have to factor out a negative 1 from there. Now I have a GCF of x minus 1. So when I factor that out, I would be left with 5x to the 3rd minus 1. Carissa, first step.
Group the first two.
Excellent. Group the first two. And then what did you factor out?
3.
3. Excellent. How many of you factored out a 3? Good. So that's going to leave me with 3 times a minus 2b. Somebody different, what did you do next? Group the last two. And Andrea, what did you factor out? 5a. So plus 5a. And that left me with a minus 2b. Okay, somebody different, what did you do next? Factored out the GCF. So when I factor out a minus 2b, what were you left over with? 3 plus 5a. Oops, parentheses. And you are done. So you will use factoring by grouping every time that you have 4 terms. You will group the first 2 and the last 2, factor out a GCF, and then factor out this second GCF of the binomial.